Myself, Rashekar Reddy. My roll number 23 4G1A0322. Mechanical branch. Subject name Engineering Mechanics. Subject code 23 ME201. Today my topic is Law of Conservation of Momentum and Work Energy Equation for Translation. State Law of Conservation of Momentum and Work Energy Equation for Translation. Introduction. The law of conservation of momentum is a fundamental principle in physics. It states that the total momentum of a closed system remains constant if no external force acts on it. This means that the momentum before an event must equal to the momentum after the event. Momentum conversion principle. Momentum is the product of an object's mass and its velocities. In an isolated system, the total momentum remains constant over time. This principle is essential for understanding collisions the and interactions between objects. Impulse and momentum. Impulse is the change in momentum of an object. When a force is applied over a period of time, the impulse momentum theorem relates the impulse applied to an object to the resulting change in momentum. This theorem is crucial for analyzing the effects of force on the motion of objects. Applications on momentum conversions. Momentum conversion is used in analyzing collisions between objects. It helps determine the velocities of objects after a collision based on their masses and initial velocities. This principle is also employed in understanding rockets and the behavior of particles in particle accelerators. Work energy equation for translation. The work energy equation for translation relates the work done on the object to its change in kinetic energy. Work, work is defined as a force applied to an object multiplied by the distance over which the force acts. This equation is a powerful tool for analyzing the energy transfers in mechanical systems. Kinetic energy and work. Kinetic energy is a work an object possesses due to its motion. When work is done on an object, it changes the object's kinetic energy. The work energy equation for translation allows us to calculate the change in kinetic energy based on the work done. Work energy theorem. The work energy theorem states that the work done on an object is equal to the change in kinetic energy. This theorem provides a different preservative on the relationship between work energy and motion. It is a valuable tool for analyzing the motion of objects under the influence of various forces. Conversion of energy. The work energy equation for translation is based on the principle of conservation of energy. Energy cannot be created nor destroyed, only transferred between different forms. This principle is essential for understanding the behavior of systems and their motions. Practical applications. The work energy equation for translation is used in various engineering fields such as mechanical and engineering, civil engineering. It helps determine the efficiency of mechanics and the energy requirements for different tasks. Understanding this equation is crucial for designing systems that optimize energy transfers and utilization. Conclusion. The law of conservation of momentum and the work energy equation for translation are fundamental concepts in physics. They provide valuable insights into the behavior of objects in motion and the interactions between them. Masterizing these principles is essential for solving complex problems in mechanics and engineering. Thank you, sir. This is my PPT.